Now in this video we'll be looking at the chemical combination and bonding. Right, we'll get to understand what chemical combination and bonding is all about. All right, now let's first of all look at the concept of chemical combination. And we know that when elements actually combine to give a particular compound, they do so in fixed proportion by mass. And as such, now let's look at what chemical reaction is about. So when a chemical reaction occurs when two or more elements combine to give a new product. Also, this also will lead us to what chemical bonding is all about. Now, in chemistry, chemical bonding can be defined as that force that exists between two or more atoms, molecules, or ions to give rise to a chemical compound. All right, now let's look at the types of chemical bonding. And in this video, we'll look at these three, and in subsequent video, you get to
The outer
understand.
shell of many atoms, hydrogen being an exception, holds 8 electrons. Atoms that have an outer shell containing 8 electrons are considered chemically stable. We often say they fulfill what is called the octet rule. When atoms combine to form compounds, they can give up, accept, or share electrons in order to assemble an octet of electrons in their outer shells. A covalent bond is formed when atoms share electrons in order to satisfy the octet rule. For example, a carbon atom holds 4 electrons in its outer shell, but it would be much more stable with 8. To gain the additional 4 electrons, carbon can share with other atoms and thereby have a completed outer shell. If one carbon and 4 hydrogen atoms come together and share their electrons, carbon achieves an octet of electrons. Note that each hydrogen in this compound achieves 2 electrons in its outer shell. This is the stable configuration of the first electron shell. An ionic bond forms when 2 atoms are held together by the attraction between opposite charges. The reaction between sodium and chlorine atoms is an example of how an ionic bond is formed. Since sodium has only 1 electron in its third shell, it has a tendency to give up that electron. Once it does, the remaining outer shell contains 8 electrons. This loss of an electron gives sodium a slightly positive charge. Chlorine, on the other hand, tends to gain an electron, since its outer shell already has 7. When chlorine gains an electron, it becomes slightly negative. The charged sodium and chlorine atoms are called ions. Ions of opposite charge attract each other and form ionic bonds. In this case, the attraction of sodium and chlorine form a molecule called sodium chloride, or table salt.
What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with 2 different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds, solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom. Hydrogen bonds are also important in the structure of proteins and nucleic acids, which we will cover in later videos. So now we know that water molecules are polar, or have a slightly positive and slightly negative end. And in fact, many lipids, or fats and oils, are not polar, so their molecules share electrons equally in their bonds. So these are nonpolar molecules. This means that when water and oil come together, they do not form bonds with one another. Even when we try to mix them, the water molecules will eventually separate because their polar molecules are attracted to one another and will form hydrogen bonds, which will separate the water and the nonpolar oil molecules. And that be the basics on hydrogen bonds.